Hi there, everybody. My name's Trent Carter. I'm here with the man, the myth, the legend, Bobby Johnston, the foil designer at Slingshot, an all-around madman. Bobby, thanks for being here today.
Thanks, Trent. Appreciate it.
So, let's talk about these Project Drag Masts. So my first question for you is, when designing these masts, did you use a different layup than you previously used for other masts?
Yeah.
And if so, how is it different?
The main difference I can really talk about is that it's solid.
Mm-hmm.
There's no core. The old masts were hollow, so while they didn't have a foam core, they were hollow on the inside. These ones are solid carbon the whole way throughout.
So this, aside from stiffness, which you'd obviously gain from having a solid mast, what other advantages are you getting?
What that allows us to do is really shrink the size of the mast down because we're packing as much carbon in. So it's really about maintaining stiffness at a level that is good around where our HM masts are, and then being able to just bring the size of the mast down to really improve the drag performance.
Excellent. So what was the goal with this mast?
We wanted to make a very fast mast, basically just something that you could win a race on, just go as fast as possible. And we also wanted to make sure that it was still fun. So while we really shrank everything down as far as the thinness and really pushed the size of the overall profile. We also shrunk down the chord to make it pretty loose in yaw. Often race masts have a bit more chord length that keeps the yaw a bit more locked in. This one is a lot looser in yaw, just to keep it more playful. So if you're ripping in and you just want to have a good time on the wave and link turns, it's great for that too.
Awesome. In your opinion, we've experienced this, but maybe others haven't. What is the advantage of a Tuttle mast just from the purely mast side of things?
Uh, for the feel, it's just way more direct. It really just like transfers to the board really well. It's really locked in. So just when you have inputs on the board, I'm sure that the board designers probably said the same thing, but the input from the foil to you is just way more snappy, direct. Just like an amazing feel. Other benefits are that it's easier to make. The pedestal, how things curve out and stuff. Just the Tuttle's super locked in one piece. So really just like ends up with like a stronger mast.
Mm,
Um, but yeah, the main thing is just the feel and the directness, just having a very stiff connection.
awesome. Um, I know you play around a lot with profiles of masts, and when we think of profiles, we usually think of front wing profiles, tail wing profiles to get lift. How important, in your perspective, or how much change can you get out of just modifying a profile of the mast?
Massive differences. Um, Eventually, I would imagine the industry that the gains are going to slow down as we find better and better profiles. The gains will slow down, but it's pretty amazing right now how far the industry can go every few years, just like further and further. But yeah, it's all important. Front wing, tail, mast. You need to reduce drag everywhere that you can.
Mm-hmm. And with the profile of the mast, like if you had the same mast with the same thickness and you were adjusting the profile, are you seeing big changes in efficiency there?
Yeah, from like a typical just like NACA profile to this mast, it's about 45% to 50% more efficient.
Wow, that's incredible. Can you talk us through the steel collar that you've introduced on this mast and the reason you did so?
Yeah, the steel collar really just locks things in for the one lock. As it's sliding and expanding together, um, the steel collars just holds things really direct and transfers it through to the carbon. Allows for really good dimensional accuracy, and that steel collar actually has tangs that run up inside the mast, so you're transferring the loads from the front wing up the mast.
Straight through the Tuttle into your feet.
The Steel tangs don't go all the way up
Right, right. But as far as the
to
energy,
the
right?
front.
That
Yeah,
energy flow, you're not losing anything really. And
yeah.
it's all going
They go
straight to the.
about like 30 cm up.
Okay. With the sport of foiling evolving so much, you see the craziest things every single day, on social media or in person here on Maui. These forces that all the equipment's facing is so much more extreme than it used to be. Where, in your eyes, when you're watching that, are the biggest weak points? Like, especially considering, like, maybe even just looking at a mass, like when you're watching someone really pushing it, what are you looking at as the main weak points of a mass, and kind of how are you addressing that?
And the connection between the fuselage and the mast, I think, is something that's really challenged brands for a long time.
Mm-hmm.
I think it's something that we really focus on with One Lock, and I think just when you have that torsional load from just that giant lever arm from the load on your front wing and your mast, where those two come together, that joint there, and then also the front wing where it comes together to the fuselage as well. Those 2 points are definitely the hardest, just because you're trying to keep them as small as possible to keep down drag, and the forces there are just huge.
So that's it kind of was that kind of the inspiration of putting the steel collar in there just to make it, if we're gonna make the bottom of the mast smaller, let's beef it up, make it super strong, and put the steel in.
Yeah,
Is that kind of the thinking there?
that was one thing that we wanted to check out. The other thing was that for the back of the collar, we wanted to taper it down as thin as possible
Mm,
to really have like a smooth water flow, like exit off of the section of the mast onto the tail fuselage. So having the metal there, it's possible to bring it down to like a much thinner section there,
mm.
so that it really just like goes off without any edge.
Awesome.
Testing hasn't shown that it makes too much of a difference on the drag, but every little bit counts. So yeah, doing
Awesome.
everything that we can to make it lower drag.
So it seems to me like you're taking the advantages of the one lock system where it's super easy to connect, and then we're making it thinner, faster, better. But we've also addressed, okay, if you're going to make everything thinner and smaller, you're going to have to make it somehow stiff enough again. So it seems like you've addressed all that. And now we have something that's faster than the high modulus mass, but just as stiff. So I think that's amazing.
Awesome. I
Bobby,
mean, I do too. Hopefully,
that's amazing.
other people do too.
Yeah. All right. Thank you very much.
Thanks, Trent.
We'll
Appreciate it.
chat soon. Bye bye now.